Excellent. So hi and welcome everyone to this latest edition of the New York HR Analytics Meetup. My name is Jeremy Shapiro. I am a practitioner of HR Analytics. I get to lead a wonderful team at Merck, the pharmaceutical company, and I'm joined today by our co-hosts and also our guest speaker, Keith McNulty from McKinsey. We'd like to just kind of lead off with just a quick round robin where we'll introduce some of our organizing committee and maybe start with Stella.
Hello, everyone. Happy to be here. Jeremy and I have been partners in crimes for a few years here and looking forward to hosting our session today. It's exciting to see the record of registration for this session. So well done, Keith. You're the star.
Absolutely, and I'll just kind of go in my picture order, which is in no real order. To maybe Philip.
Hey, yeah, I'm Philip Ockel. I'm the founder of a people analytics company called Worklytics. I have been part of the group for around 3 or 4 years now. I can't remember exactly, something like that. I did move to Seattle, so I now log in remotely to these sessions. One benefit of COVID is I can still access them because they're online and not in person.
Exactly right. Yeah. Thanks, Philip. And over maybe to why don't we go to Paula?
Hi, everybody. My name is Paula Barrios Sanchez. I'm in similar location with Stella and Jeremy around New Jersey area in the United States. So I joined the team also a few years ago. I'm a talent strategist, so I combine analytics with talent strategy and business approach. So I'm an independent consultant coach and recently joined a company that combine technology, analytics, and science called Connexa. So looking forward to hear more about what everybody's thinking in this meetup today. And of course for Keith, record registration. So looking forward to that.
Awesome, thanks Paula. And we'll go over to Miriam.
Yeah, hi. I think I'm the only, like last time, the representative of the New York Strategic Analytics team that's in New York right now. But one of us has to hold the fort. I work at a company called TapRecruit, and we help companies write better job descriptions. And I'm also part of, I teach with Stella and a number of other members, including Bennett of our team, as well as of our meetup at NYU in the Human Capital and Analytics and Technology program. So I'm actually really looking forward to this because I teach statistics. And Keith, we're very much looking forward to your discussion of regressions because I think that will make it really interesting for my students who are here as well. So
awesome, thank you. And we'll finish with Bennett, not last but not least.
Hi, everyone. Bennett Voorhees and my father in the background. 2020 pandemic, hashtag. I'm really lucky to lead the data science team in Merck's human capital or workforce analytics team, MSD as it's known out of the US and Canada. And I also am a faculty at NYU SPS teaching data science, introduction to data science course there. And I'm really, really excited about today's session. Thank you so much, Keith. I think that you have given us a really important contribution to our field and also a very generous one. So I'm really, really excited about today's session and really happy about the number of faces new and old on the call today.
Awesome, thank you, Bennett. So we're just going to take a moment to get to know you as well, and like happens on many occasions, we will do this in polling too. So Stella is putting up a poll, and if you would just kind of answer to your greatest deal of comfort, and as you are voting, one other thing to just know is all interruptions, cats, babies, dogs, significant others, insignificant others, they're all welcome on our call today. So please, like it's important for us to be your full self, particularly this is the afternoon, evening, and for some mornings as well. So please be your full selves on the call. So it looks like we have our first result here. So a solid 50% of us. This is your first time here, so welcome. If you were not anticipating having a conversation about analytics, in statistics. This is certainly your time to gracefully bow out, but I see the numbers are going up and not down. That's great. Maybe we'll do the next question. Let's see here, and let's see, polling number 2. Let's see here. I think, oh, we have one more. There we go. And this next question is, tell us about just kind of your relationship to data science. You know, and Stella and I can kind of see the rapid polling as well, and we also do this to make sure that Keith gets a feel on who you are and what you're doing too. So that's always very helpful, I find. And we're very close with 88% voting too. So it looks like the vast majority of us are practicing in an analytics or data science function, some inside of HR and some outside of HR. As well. So for those of you who are casual observers and interested in the topic, the one thing that that I think is exciting and also to not be, I'll invite you to not be intimidated about on our call today is, it may get technical. It's okay too. You know, feel one of the phrases that I appreciated the most from 2020 is start feeling comfortable being uncomfortable. As well, and that can be applied in many realms, and I think this is certainly one too. So why don't we get? I'd love to introduce Keith just for a moment and hand the floor to you. So Keith, you know, you and I started chatting with each other. It seems like years ago, but also seems like days ago as well. So Keith has been a prolific open source sharer of your knowledge on LinkedIn for quite a few years. You know, when you wrote me your bio, you said that you used to be a mathematician, and I think we can qualify that you still are as well. So I think you get to keep that as well. But you've been at McKinsey for 22 years in progressively larger and larger roles, and you know, further focused in people measurement, psychometrics, and in analytics. One of the things that I appreciate about the work that you do and how you share it is the passion that you bring to both mathematics and statistics, and also methods as well in this area, in this area of the soft squishy stuff. And so for those of us who do this on a day-to-day basis, we try to find the key areas where you can tell a data-driven story and find true evidence, but in areas that some folks outside of our area don't necessarily know. You are the most recent author of the book that brought you here today, which we're very excited to hear your views on. It is hot off the virtual press, called The Handbook of Regression Modeling in People Analytics. If you clicked on the meetup and didn't know about the book, we will post it into the chat. I suspect many of you did as well, and are eager to hear kind of the author's thoughts. Keith, your thoughts on how you got there and what you're thinking now. And so I'll hand the floor over to you, and maybe you could start us off by just kind of telling us what made you do it. Why did you start writing this book, and then maybe then sharing it with the world as you did?
Yeah, thanks for the intro, Jeremy, and thanks for the enthusiasm from everyone. I hope I can live up to the expectations that have been laid down here. Jeremy's right. I used to be a mathematician, but I will stress that I wasn't a statistician, and there are big differences. In fact, I hated statistics. I had to do one course in it during my undergraduate degree, and I walked out of that course, took the last exam, got the worst score of my entire program on that exam, and then was glad to say goodbye to it. And so somebody had told me back then that nowadays I would be spending most of my time doing statistics and enjoying it. I think I would have been pretty shocked. And there's two reasons, I think, why. And one is because they were trying to teach us statistics back then with no data. And I think that's just silly, right? Because statistics is about data. And if you can't engage with data, you'll never really learn and develop a passion for it. But I think another was I actually found a space where there was just such huge potential for the topic, right? And you know, around the time that I moved into I've been doing people measurement work for a long time, right? I helped kind of set up McKinsey's recruiting processes and development processes by putting real good psychometric and measurement principles behind it. And I started that process 15 years ago. And say 5 years ago, we then, as a result of that, had 10 years worth of really good data. And suddenly with all these data science tools coming out, the potential was suddenly there to do really interesting analytics. And that was never there before. And one of the points I make early in my book is, you know, if you entered the world of work when I did in the early noughties, there was no such thing as a data-driven approach because there wasn't any data. That's changed so much in this period of time. So it's a pretty exciting time to be working, particularly in a field like this where there's so much space to improve. But I think one of the reasons why I wrote the book, and it's something that I've been thinking about for a while, is because I've been a little bit frustrated about, I don't feel there's enough clarity and direction on methods in this space, right? So I think what's happening is people are going to education programs, they're learning about a lot of different things, but then they're coming back into their work and they're not 100% sure what fits with what and what should be applied to what problem. And particularly one point I want to make here is the difference between inferential and predictive modeling. And this is something, if you look at chapter 1 of my book, I kind of go into this quite a lot. And for me, it's very important because what I see things happening like this. I see somebody coming up to an analyst at work and saying, can you generate a model for me that predicts something? And the person goes away, they use like Python, scikit-learn, they use some sort of complex, you know, random forest or neural network model. And then they come back and they say, hey, look, I've got like you know, an area under the curve of 0.85 here. It's brilliant. And then the person says to them, okay, so tell me what predicts it. And they go, oh, I'm sorry, my model's too complicated. I can't tell you that. And it turns out that the original question was not, can you predict it? The original question was, can you explain it? And it's my point of view from my experience so far that the vast majority of situations in people analytics, the question is asking someone to explain an outcome. Prediction exists in there, but it's one of the smaller use cases in people analytics. So I wanted to try to use this book to have a reset and to help people get to grips with what methods do you use to explain things. You know, that's what people really want to know. If they, like nobody, it's rare that people would say, I want an algorithm that predicts performance, but what they do want to know is, okay, what is it that explains performance in our context? And the tools are very different for those two purposes for a number of reasons. So really that's the first thing I do in the book. I make that differentiation, and the book is very much focused on inferential modeling, which is about explaining, not about predicting. Now, some inferential models can then be used to predict, but there's a different process as well when you do it that way. For example, with predictive model, you need to leave some of your data out so you can test your predictions. Whereas if inference or explanation is your only purpose, you don't need to leave any data out to do a model like that. So that's kind of one of the important points I want to make here. The second thing really is that, you know, I'm going to talk about a few things today. I'm actually going to, you know, go through an example because I think that's the best way of learning. And I saw on the poll as well, there's some technical people here and there's some non-technical people here. There's coders and there's non-coders on this call. And this material should be valuable to both types of individual. Because it teaches a couple of things, right? It teaches how to do the actual modeling itself. But it also teaches, once you have results, how do you interpret that and how do you bring it back to the people who asked the question? And one of the things that I think, even if you don't code, if you're working in any sort of analytics space, it's extremely valuable to know what type of modeling can be done. And when you get results, what do those results mean and how can I explain them to my stakeholders? And this book tries to do all of that. So it really starts at the point of modeling and it moves through to, okay, well, when we get these results, what do they mean? How do we interpret them? Now, when I thought about what I do on the session today, one of the things I thought is, why don't I just talk through the book at a high level? But then I thought, well, actually, no, because people can read the book if they want to. So I thought what's more interesting is, let's go through a real example, right, that actually pulls on different parts of the book. And then I can reference what parts of the book that it refers to. What I'm going to do on this session is, I've actually got a new data set. It's not one of the ones in the book. It's very relevant to a typical HR problem. And I'll actually talk through how I would go about addressing, that question and take you through the various steps of it. So that's kind of what I plan to do. Now, because there's so many people on the call, what I'll probably do once Jeremy gives me the go ahead, I don't know if Jeremy, if you want to, jump in before I get started on this process.
Well, the only thing I would say, and for those that are joining in, welcome, and please do kind of say hi in the chat. Cameras on is fine. If not, it's fine too. Is if you, as we're going through this, if you have questions, no question is out of bounds as well, at least related to the topic. To please put it into the chat, and it just up to everyone. Stella and I will moderate that queue. And if someone has asked the question that you're interested in, just kind of do a +1 and maybe just give us a few words of the question you're talking about. And then Keith, as we go through, we'll feed you as well.
That's great. I have what I've set up is a kind of a fairly linear talk through a problem. So what I'll probably aim to do, if it makes sense to everyone, just because there's so many people, is actually just get through that. So talk through the various steps of it and what's involved. And as you register questions, then we'll make sure there's time at the end. Can I also confirm, guys, how long have we got here, just so I know what time I'm working to?
So we blocked 90 minutes,
Okay.
but we don't have to take it. If we run out of time, we can bring you back for the second tour.
Okay. So just so I know, so I stay on time. So what I'll do is I'll plow through that at a reasonable pace. And then what we can do is, as you've registered questions, I'll try and attack whatever questions come my way after I've gone through that process. Stella, are you able to kind of send out a link to the actual presentation? That would be great in the chat. So there's a presentation which you can actually open up yourselves in your browser or on your smartphone, so you can go along with it. And it's, but I will also screen share so that at this point, so that you can actually see what I'm seeing. So let me just pull that up. Okay. Okay. Now, hopefully you're seeing a slide presentation here with a big R in the corner.
Yep.
Great. I might actually swap over and do a bit of live coding during the session, depending on how we go. So if you're not seeing what I'm seeing, can somebody just unmute and give me a shout?
We'll take care of it. Yep.
The topic I want to talk about here is very relevant to HR, right? And probably a very common question in HR, which is, can we explain performance ratings? Lots of people are interested in performance in a people context. Performance has usually performance ratings have a very particular shape, right? They have a scale, and there's usually a few points on that scale, like a Likert scale. In the simplest form, which is the form I'll use today, just for getting through things quickly, you would have a low, medium, and high performer, right? A 1, 2, and 3. But you might have more complex 1, 2, 3, 4, 5, or it might even be more in some cases. This method would work for any situation like that. So this method is intended to deal with situations where you're trying to understand an increasing ordinal scale. And the method is called proportional odds regression. And I picked this today just because it's one of the more common methods that I use. And I think that kind of makes sense, because a lot of the outcomes in HR are on an ordinal scale, like survey ratings or performance ratings. All the code is available. I put links in the document when you get it. And I've done this in R, mainly because, amazingly, this is a method that's still not available in Python. And I don't know why, but apparently they're planning to release it soon. So hopefully for Python users, you'll be able to get your hands on this particular method in the near future. So we're going to be looking at a data set of that relates to salespeople. And in this data set, you can see it here. I'll actually pull it down in my live coding session. Did that screen swap over for you guys? Good. So here I'm just going to download some data, and I'm going to read it in and look at the first few rows of it. So we've got 5 columns. The first column is a sales figure, which we'll say is in millions of dollars that a salesperson has made during a year, say. The next column is the number of new customers they've brought in over that year. Then we have the region, which is going to be just north, south, east, and west that they operate in. And then we have a gender, in this case, just male or female. And we have a performance rating, which is on a scale, an ordinal scale 1, 2, or 3. They're either 1 is low, 2 is moderate, and maybe medium, 3 is high. And the question that we're being asked is, how do these 4 factors on the left influence or explain the rating? What pops out on the right? So we're not looking at the point I made earlier is the aim is not to predict, the aim is to explain here. So I'm going to be using an explanatory model or an inferential model. So now one of the things we can do straight away, right, is we can actually take a look at what our data looks like. And for me, that's the first thing I always do. Before I even think about a model, I say, well, when I've read it in, what does it actually look like here? And particularly, what form does each piece of data take? So if I run this particular command, structure command, it'll tell me a little bit about what each column is here. So it says there's 5 columns, of which the sales is a numeric column, new customers is also a numeric column. Then we have a couple of columns, region, gender, which have been read in as character columns, so basically character strings. And then a rating column, which has been read in as an integer. Now, there's a few problems here. And sales and new customers is fine. But region and gender are not actually character strings, because a character string means you can put anything in there, right? But actually, there's only 4 values it can have. Region can only be northwest, south, or east. And gender, in this case, can only be male or female. So these are categorical data sets. I need to change that to work with categories here. And then rating is also a problem because it says it's an integer, and an integer means it can have any positive value, but actually it can't. It can only be 1, 2, or 3. We also know that those have order, right? So 3 is greater than 2 is greater than 1, which is different from the earlier 2 columns. They're categories, but they don't have order. So I need to do some changing here just to make sure I'm working with the data in a way that makes sense for the problem that I'm dealing with. Right, so what I'm going to do is I'm going to run some code on this data. This code is basically going to convert my 2 categorical columns to categories, or factors as they're called in R, and my rating column to an ordered rating. So I'll just run that. And then afterwards, it tells me what my data looks like now. So now I have in 2 numerical first columns, which is fine. Now it knows that region and gender are factors. Region has 4 levels, gender has 2 levels. And rating is an ordinal factor. So it has 3 levels, of which 1 is less than 2 is less than 3. That's exactly how we need it. That's very important because the rest of this code won't work if I hadn't done this. So there's this important very first step of just saying, okay, well, what problem am I trying to solve, and is the data in the right shape to solve that problem? So now that I've done that, swap over here. Before you model, it's sometimes useful to just kind of have a quick look at the data. You know, are there any obvious patterns here that I might expect when I run my model? Now, a model is going to be multivariate, but you can do a bivariate visualization, right? You can just look at how each of these columns might relate to other columns to see if there's anything interesting in there. And a pair plot is a great way of doing that. There's some very simple commands in R that help you run pair plots. So here you have a pair plot. I'll actually, I won't code it up, and I'll just show it to you here. So what we can see here is down the diagonal, it just shows you the distribution of each variable, right? And particularly down in the bottom right-hand corner, you can see that ratings are relatively evenly distributed around the 3 categories, which is actually a bit unusual, right? Because you find in most rating systems, everybody picks the middle. But here we've got a reasonable distribution, so that's nice to see. We can also see here that if we look at sales, that seems to have an interesting relationship with rating. And new customers also seems to have an interesting positive relationship with rating. And if we look at the other two, region and gender, I can't really see anything massively different there. So it doesn't look like we might find, but we might be surprised, but it doesn't look like we'd see a big relationship between region and rating, or gender and rating here. The other thing to look out for when you do this is what's called multicollinearity or collinearity. So are there variables that have a really strong relationship with each other? Here particularly, you see that new customers and sales have approximately 0.4 correlation. And that's probably not surprising, right? If you're generating a lot of new customers, then you're probably generating to some extent, a lot of sales as well. Now, generally, if you wanted to do something about this, you don't want to, in any multivariate model, you don't want to have really high correlations between your input variables. For me, I'm okay with 0.4. If it was any higher, I'd start to get worried. And certainly where it gets very bad is when you get up to 0.6 and 0.7. But that said, there's some things that this affects in the model and some things that it don't. So even if this correlation existed, there would be some results of the model that really wouldn't matter for, and there's some that really would matter for. I'll talk about that as we go through. But this is a very useful kind of technique to just get your head around the data. So I'm going into this now thinking, I might expect to see a relationship between ratings and sales and new customers. I'm not so sure about region and gender. I probably don't want a relationship with region and gender either, right? Because that might be indications that you've got some bias in your evaluation processes. So it would be nice not to see that, I think. Great. Now, there's actually, generally when we run an inferential model or an explanatory model, there's three big questions we try to answer, right? So one is, which of the variables are actually meaningful in explaining your outcome? So which variables here are important in explaining performance? Second of all, and this is where inferential or explanatory model really comes into its own, it's like quantifying that, right? How can I articulate the degree to which each variable influences that outcome, that performance, which is often very difficult to do when you're running predictive models. And then finally, this last question, which is, okay, well, I've looked at all these variables. Can I estimate how much of the outcome these variables explain? Maybe it's only a tiny part of it, maybe it's a huge part of it, but that's important to know, because if you have all these nice relationships that you've spotted, but they only explain 10% of your outcome, you need to tell your stakeholders that, because otherwise they're going to run away and think, wow, fantastic, we found the entire solution, right? Which they haven't, and rarely you will do that. There's very few models where you'll explain the entire outcome, at least in our space. So these are the three questions that we're going to try and get our heads around in this session. So we'll start with the first one. Now, before we even do this, we have to choose the right type of model, right? So what I've done in my book is I've actually laid out all of the major types of explanatory models that you would typically need to use in a HR analytics or people analytics context, right? There may be some rare models that you'll need that are not in the book, but most of the models that are in this book will cover the vast majority of typical questions or explanatory questions that come our way. And first thing you'd have to do is choose, okay, well, which of these models would I use? There's quite a choice here. So the first question you'd ask, most important question usually when you choose a model, is what type of outcome are we studying, right? If it was a linear continuous scale, like you were modeling compensation, or you're modeling height or weight of an individual, then that would be a linear model, and you would go down that route. If it was a binary outcome, like if somebody promoted or not, that would be what's called a binomial logistic regression. In this case, as we've identified earlier, we do have an increasing outcome, but it's an ordinal scale, right? So it's 3 increasing values. And that's called an ordinal, that's ordered category. So we know that that's our outcome. So we know that we're going to use some sort of ordinal regression model here. The next question we need to ask is important. And sometimes we don't actually know the answer to it. We have to run the model and then check it afterwards. But the next question is, can we assume that each of our inputs act in a similar way on each level of the outcome, right? So if we have a situation where one of our inputs might actually explain the top performance a lot more than it explains the other performance levels, we might not be able to use the type of model I'm going to show you now. So the ingoing assumption for this model is that the input variables we're dealing with have a reasonably, even effect on each of the three levels of the outcome. And if we are happy with both of those, and as I said, with question 2, sometimes what we do is usually run the model and go back and check whether we're right on question 2. We use what's called a proportional odds logistic regression model. And that's because you have an assumption, which is your assumption in question 2, which is the proportional odds assumption. And I put an appendix page in this document to show you how you can check that assumption after you've built the model. Section 7.1 of the book is where I actually go into the mathematics of this in a little bit more detail. And one thing I would say, particularly if you are somebody who does the modeling, I would really encourage you to dive into the mathematics, because what I find is that if you don't really get the mathematics, then you struggle to explain the models to other people. So it is worth, sometimes it's a little bit of pain, but it is worth getting in there and trying to get your head around it if you don't know the stuff already. So let's actually run the model, and I'll pull this up. So this model has actually been around in R for a long time because it comes from a library called MAS, which is from the book Multivariate Analytics and Statistics in S, I think it's called, or something like that. And S was actually the predecessor of R and dates from like the late 70s and early 80s. So that tells you how long this package and this function has been around. So we're going to use a function here called POLAR, which stands for Proportional Odds Logistic Regression. And all of the model functions tend to have a formula put inside them, right, to tell you what you want to regress against what. So your data set might actually have 100 different columns in it, but you might only want to put some of those columns into your regression model. In this case, what you'll put on the left-hand side of your tilde is the outcome. And then on the right-hand side of your tilde, you'll put the input variables that you want to regress your outcome against. So here, I could write, rating tilde, and then I could put actually the names of the 4 columns with a plus between them if I wanted to. But actually, this is nice little shorthand. This period here means I want to regress rating against all the other variables. So it's a nice little shorthand. So I'm going to take that formula and I'm going to use the data from my employee performance data set. And I'm just going to run that model here by running this code. Now it's run. Okay, we can't actually see anything because the model's sitting there in memory. But we haven't looked at the results. We have to take some steps to look at the results. But the model ran in like 1 second, and that's what I love about R. It's just amazingly fast at times. Okay, so now we have a model sitting and ready to be looked at. Now what we're going to do, just pull this up. We have to say, how do we look at and work out what the results are telling us of this model? So one of the things that I show later in the book, in chapter 10, which I don't use in earlier, but it's for people who like to have tidy results when they run their models, is how to create the results of your models in nice tidy tables that are well organized. And because all these model functions that we use, whether it's POLAR or others, they come from years and years of different R development. And so they all come out in different forms, and that can be hard to manage. So here I'm using some functions to just make sure I get the results out in a nice and neat form. So I'm going to use this package, Broom, which means it's called Broom because it tidies things up. It spits the model results out in a kind of a nice and neat form. I'll just run that here. So what we see here, right, in the results of the model, it has here our terms in the left-hand column. So what we see in our terms, they're actually our variables, right? So we have sales, we have new customers, and then we have the other categorical variables broken out. So we have region north, region south, region west, and we have gender male. Now the reason these are broken out like this is because somebody is always one of these 4 region categories, right? So the way that the model works is it tells you, okay, our base category is obviously here region east, because it doesn't appear in the data. So the region north means what is the effect of moving someone from region east to region north. Similarly, region south is what's the effect of moving someone from region east to region south. Similarly with gender, female gender is obviously the base category. So the gender male estimate here tells you what is the effect of somebody moving from being female to being male in the model. So if your data is categorical, the results come out in a particular way for those categories, right, in a model like this. Here we have our coefficient estimates. We'll have to think for a minute about what these actually mean. And here we have standard errors around those estimates. So basically, they are estimates, which means that this number here is very, very precise. That doesn't mean, in truth, it is that number. It means that there's a range of values around that number that it could be. And your standard error helps you understand what that range of values is. And then finally, you have a statistic, which helps you understand, how extreme is this result. So high statistics means this result is very extreme. What we're really trying to understand here is the first question you'll remember we're trying to answer is which of these variables are meaningful, actually have a meaningful effect. And to have a meaningful effect, we have to be sure that the coefficient estimate is not 0, because 0 means it has no effect, okay? So what we can do, a shorthand for doing this, I'll show you how to do it more precisely in a second, but one shorthand way of doing this is to talk about what is the 95% confidence interval around the estimate. What's the range of values that we're 95% sure contains the real coefficient here? And you can normally, as a rule of thumb, find your 95% confidence interval by subtracting 2 of the standard errors from the estimate and adding 2 of the standard errors to the estimate. So if you can see here for the sales coefficient, even if you subtract 2 standard errors, you're still way above 0, right? Similarly, for new customers, you're way above 0, even if you subtract 2 standard errors. But for regions and gender, if you subtract 2 standard errors, you're crossing 0, right? So we can tell straight away that sales and new customers are going to be significant variables in this model. The others are not, just by that kind of rule of thumb. What we can do to get a more precise point of view on that is we can actually calculate a p-value for each of those coefficients. And the p-value tells you, what's the significance of this coefficient. If the p-value is less than a certain standard, which is usually 0.05, then that means the coefficient is not really statistically significant. And the consequence of that is you can relatively safely drop that variable from your model because it doesn't add value in explaining your outcome. So I've got some code here which will convert the estimate column to a p-value. And I'll just run that now. And here we have this new p-value column at the end, and you can see that the p-value for sales is extremely small. The p-value for new customers is so small, it's actually 0. And there's reasonably high p-values for the other variables. So we can conclude that sales and new customers are meaningful explanatory variables in understanding salesperson performance, but their region and their gender are not. And that actually means that we can drop region and gender from the model, which is helpful. It's always a good idea to do that if you can, because the simpler your model is, the easier it is to explain to your stakeholders. So it's always a good idea to do that if you can. So I'm just going to quickly run some new code which simplifies my model. So I now have a new model which just tells me sales and new customers and how that influences my rating outcome. And now I'm ready to move on to the next question, which is, how does each variable affect performance? So here's where we need to do some work around our estimate, because our estimate here tells us something interesting and useful. You can see here, for example, that the coefficient estimate for sales and new customers is pretty similar. So whatever effect these are having, it looks to be approximately the same between the two variables. But it doesn't have a lot of meaning as it stands. What this actually represents is something called the log odds, which is the logarithm of the odds. And that doesn't have, it's not particularly helpful or intuitive to understand that. But what you can do very simply is convert this to what's called an odds ratio. And the odds ratio is very interpretable, and I'll explain what it means in a second. But let me just run this. So in this code, I'm going to just create an odds ratio from the estimate. The odds ratio is simply an exponent of the estimate. You can see a very simple equation here. Odds ratio equals exponent of estimate. It's quite simple. Now we have this new column called odds ratio. And the odds ratio tells us the multiple of the odds of being in a higher performance category, assuming that the other variable or variables stay the same. So if I'm interpreting this, what I'm saying to my stakeholders are, if you are an individual with a similar number of new customers, then each $1 million in sales gives you a 46% higher odds of being in a higher performance category. And I'm saying that if you are an individual who has similar sales levels, then each new customer you acquire gives you approximately a 48% higher odds of being in a higher performance category. So you can see that this is kind of a nice way of explaining that if you consider additional sales as every $1 million, and if you you can basically say that every $1 million has approximately the same effect on your odds of higher performance as every new customer, additional new customer that you acquire. So it has this nice ability of you to be able to articulate the strength of these explanatory variables on your outcome. And this is something that I do a great deal in my work. You know, people always want to know for individual, for individual variables, what's the effect of those variables? Does one have a greater effect than others? One point I really want to make is that this odds ratio, or this column here, the odds ratio, really depends on the units that you're using for your input variables, right? So if you had a column of odds ratios here for a whole bunch of different coefficients, just because one has a higher odds ratio than another doesn't necessarily mean that variable is more influential in your model. It depends on the scale of your input variable. So for example, sales we know are being measured in millions of dollars. If they were to suddenly be measured in tens of millions of dollars, then your odds ratio would be a great deal higher. It would actually be 146 point something because you've changed your scale. So the meaningfulness of the odds ratio depends on scale of the input variables. And that's really important because some people can be very tempted to just rank the variables by their odds ratio and say the one with the highest odds ratio is the most important. That's not the case. It really, they have to have the same scale for that to be the case. So that's the answer to the second question. And the third question we had was, how much of the overall variance in performance can be explained by this model? You know, does it explain a small amount of performance or a large amount of performance? And, you know, if this was a linear model, right, where you're modeling some linear outcome like compensation or whatever, you would use an R squared. And an R squared is a particularly well-defined metric in linear modeling, and it will tell you to reasonable precision how much of the variance in your outcome is explained by the model, by the input variables that you're using. But in this type of modeling where you're basically modeling probability rather than linear scale, there's nothing there that's quite as simple as an R squared. But statisticians have invented something called a different variants of what's called a pseudo R squared. It's an attempt to replicate the R squared using more complex methods. And there are different variants of it, which can deliver different numbers, which means that you have to be really careful when you're talking about this. So here, for example, I can run, and again, the beauty of R is that there's really simple functions that just deliver it to you, these results to you on a plate. So here I can run a function called pseudo R squared from the desk tools package. And I've asked for two particular variants. There's actually like 7 variants of this. that are out there at the moment, but two that I tend to use a lot are the Cox-Snell variant and the Nagelkerke variant. And you can see here that they both come in around about the 0.50 mark. But because of the uncertainty around how you measure these things for logarithmic models, and because the different forms of this function deliver different results, you have to be a relatively generic in how you articulate the results for these types of models. So I tend to say, you know, it's estimated that sales and new customer acquisitions explain somewhere around half of the variance in performance. I certainly won't say it explains 0.56 of the variance in performance. That's just far too precise for this particular type of measure. But that's useful, you know, to know that half of our variance is explained kind of tells us, okay, well, they are pretty meaningful. They get you half of the way to your next performance rating, but there's clearly other stuff here which we've not got in our data set. A lot of that will be, you know, unmeasurable, unpredictable manager judgment and things like that we don't capture in data. But the pseudo R squared is useful to kind of quantify that. Now, the beauty of this model, I always like ending up with models that have only two meaningful input variables at the end. We've got 3 dimensions now left, which means we can actually visualize it if we wanted to. So I've pulled up, I'll run a visualization here. It's also in the document. And I've put the code for doing this in the document for people that like running visualizations. So here's a visualization of a 3D visualization of our model. Just turn it around to look nice and symmetric here. And what we've got here is that the green is the probability of high performance. So you can see that when people are down at the kind of low amounts of sales, low number of new customers, the probability is close to 0 of high performance. And then it increases. And then when you're up at the high sales and high new customers, you're up at close to 1 for high performance. The blue curve is the probability of the bottom performance rating. So if you're very high on sales and new customers, you're going to have very low chance of being in the bottom performance group. But if you've got high new customers and if you've got low new customers and low sales, you're going to have a high chance of being in that bottom performance group. And then you've got these guys in the middle, right? Who are somewhere between the two. And this is kind of an interesting diagram because it helps you understand how predictive models might work if you're interested, right? So there is actually a version of proportional odds in Python which you can run for predictive purposes. And the way that would work is like if I turn this on its head and look at this from 2 dimensions, right, as I'm doing here, basically our new customers and sales form a 2-dimensional space, a 2-dimensional plane here. Basically anyone to the left of this line that separates green and yellow, if this was to be applied to prediction, anybody who fell in that space would be predicted to be a high performer. Anyone who fell in this plane of orange would be predicted to be a middle rating, and anyone who fell in this zone, which is down the lower end of new customers, the lower end of sales, anyone in that entire space, that would be predicted to be a low performer. So you can see how, you can see in this 3-dimension how the model can also be used to predict for new data if it needs to. So let me just see what I've got left here. I think I've got through it relatively quick. Just for you guys, if this is new to you or if you want to dig into it further, this particular type of model, 4 chapters would be particularly important to dive into. So the first would be chapter 3 on foundational statistics. So that explains, what are confidence intervals, what are p-values, what does it mean for something to be meaningful or significant. Chapter 4 talks about the foundations of regression. So chapter 4 is really linear regression, but a lot of what's in chapter 4 is stuff that you will use later in other types of regression. So it's very important to proceed in the book. Very difficult to proceed in the book without reviewing chapter 4. Chapter 5 is about logistic regression, which focuses on modeling probabilities, which is a big part of the model I've just shown you. And then finally, chapter 7 is the specific model that we looked at here, which is the proportional odds model and the mathematics behind that. So that's particularly, those are the chapters that I would look into if you want to dig further into this. And I've done it in 30 minutes, I think, which is not bad. There's a couple of appendices here. I'll just, there's an appendix for, you mentioned earlier that I mentioned earlier that we made some assumptions that this was, that there's proportional odds here, that each of your input variables affect each level the same. You can check that here, and I've shown you how to do that, in which case it has passed that test. You can also do a test to say, actually, is my model good? Does it do a reasonable job of predicting the outcome that I'm supposed to predict? And the answer is yes, and you can see the code for that here. And I've also added the code for that 3D plot if people are interested in playing around and kind of generating that graphic output. But that's kind of everything I wanted to go through. I'm happy to stop talking now and
awesome,
and kind of take questions.
Keith, well, in record time, and so one, thank you for the walkthrough. There's questions coming in now, and first I'd like to compliment the whole meetup here, because there were a fair number of questions asked and answered by other participants in there too. So got it, awesome, and kudos there. I know as we were moderating the chat, there was one question I noticed back on page 13 that I don't. Kristen had one question that was not answered by the hive mind. So I'm just going to repaste that into the chat here. So Keith, that'll be the latest one.
Let me just pull it up
there, and then we'll kind of start with some of the unanswered questions. We can start with the chat, and then after we kind of flow through there, we'll go live if you want to ask Keith anything.
It's a good question, Kristen, and the answer is that you're right. It is a 350% increase in odds, right? So one means the same, an odds ratio of 1 means you've got exactly the same odds. So you've increased your odds by 3.5 on a base of 1. So it's 350% increase in odds.
Awesome, thank you. And then I'm just gonna, if we scroll up just a little bit, and I'll just start pasting them in here too. This is from Joel Abraham as well, and so it's a larger question. So Keith, we'll give you a moment to digest, and as folks are typing in other questions, we'll let Keith kind of read that a little bit. I don't want to mess that one up.
So this is which one am I looking at?
So this is broader question beyond specific models.
Yeah. I mean, this is obviously a difficult question to answer, right? Because it really depends on the organization that you're working for and what they want and need. One of the problems, I think, particularly in people analytics, right? Because it's the latest cool thing for a lot of organizations. And the danger is that people kind of get thrown in by someone and says, we want to do people analytics. And then when you ask that someone, okay, well, what do you want to do? They say, well, you tell me. You know, the first thing you do is in my opinion, is you find out, you know, what are the burning meaningful questions in the organization, you know, because each organization is different. And then you plan out building the capabilities to address those burning meaningful questions. And maybe the first burning meaningful question is, you know, how can I actually see the data I need to see? You know, there's metrics or reporting that I need to see, and I'm not, you know, my staff don't have access to it. So maybe then your first priority is, okay, well, before I do anything else, I just need to make sure that I have some capability or tools to get the, you know, this data into people's hands in the form it's needed to, in a quicker time. And there I would prioritize reporting tools and things like that. But once you get past that, and by the way, there's a document I would recommend, an article that a couple of colleagues and I wrote, which you can find on mckinsey.com if you look it up, but it's called How to Be Great at People Analytics. And it has a staircase framework on it, which people have found really useful. But once you get past that basic reporting part, one of the big questions, which I've referenced earlier, is, do people want me to use people analytics to explain things or to predict things? And really understand what that difference means. 90% probability is that they want you to use people analytics to explain things. And then I would focus on, if that was the case, I would focus on building up some statistics expertise and understanding how do I run and appropriately interpret models. Because I think the big problem in this space right now is there's a lot of people just running models and not really understanding what the results mean, and therefore not communicating the results of those models very effectively. And I would really prioritize that if you possibly can.
Keith, you know, it's an appreciated comment. In prior meetups, we've spoken a lot about the role of the people analyst to decode decode the request into its components. Don't look too much into exactly the words that they're using, because it's very likely they may try to use a term of art, a technical word, but not mean that as well. So look at a 2x2 table and they say out loud, "Oh my goodness, look at all the correlations." And of course, that's not what they mean. They're saying, "I think by my naked eye, I see a pattern." So how do you decode that into something that's going to be much more decision useful as well, too? So that's great. And we're gonna move over to Scott, and Scott's question is, I think, to do with the 3D visualization, which I think is a very powerful way of live narration of patterns too, to a sufficiently technical audience. You know, if you have leaders that are technical, it's a very good way to explain things. So he's interested in applications of using k-means in that type of modeling. It seems like a UX versus a statistical manipulation question.
Yeah, so k-means is a non-parametric model, right? So and kind of I cover a bit of this in chapter 1. A parametric model is a model that has a formula behind it, right? Basically you have your x's, your input variables, and when you know the value of x, you immediately know what the value of y is as a result of it. A non-parametric model is a model where you take your values of x, but you need a few other things before you can tell what the value of y is. And in k-means, for example, you would want to know, based on your values of x, what cluster that places your data point in, and then it will tell you your value of y as a result of that. I find that k-means and those types of methodologies they're really unsupervised learning methodologies, right? So they're there to help you understand hidden patterns in your data, which then could be brought into explanatory modeling later, right? So for example, you might have a whole bunch of people taking training or learning programs, and the data's a mess and you can't really see if there's any patterns or archetypes. You could use k-means to say, okay, well, are there people here that kind of fall into different groups based on their learning behaviors? And then, and somebody's just commented here, it's an exploratory method, right? So it will help you identify, okay, well, if I wanted to simplify this, I could break these people into 3 or 4 clusters. And then you could feed those clusters into your model to see if it tells you anything, into another model, see if it tells you anything. It's really an unsupervised learning method to try and, take a very messy set of data and put some structure based on patterns that you can't necessarily see just through simple analysis, right?
Awesome, thank you. And then I'm going to do one more technical, and then there's some that are kind of broader questions that are philosophical, and we can open up to the wider audience too. And this is from Felix, talking about simpler alternatives to regression, correlation weights, unit weights. Felix kindly put a link into some of those as well. But his question is, how do you choose which method to use, or do you need to test all the alternatives? So kind of in selection of methods.
Yeah, so Felix, my point of view is that you need to have experience to select the right model, right? So if you're starting out, it can be a challenge, right? Because you've got all these models kind of up in your face, and it's not 100% clear which one you should be using. And I've only built that skill through doing lots of models, right? And through learning that, oh crap, I used the wrong model, and then realizing that what the right one was. But I guess one of the reasons why I've written this book is that you'll notice that each chapter in the book has something that says the kind of origins and intuition of the method, right? And what I'm trying to do in that first section of each chapter is give you guys an intuition for what does this method do, so that when somebody takes a problem to you, you might be able to say, that's perfect for proportional odds, or binomial regression is the right method for that. That's the point I'm trying to get people to. And I don't think there's, the book helps, but I don't think there's any shortcut to this other than just doing modeling and getting experienced at it, in my opinion anyway.
Awesome, thank you. And there's one more technical question, then we'll go broader. And this is from Hussein. Thank you, Hussein, which was, how different would the results look had you run a multiple linear regression model?
So what I ran in that model was a multiple regression model, but it was proportional odds regression. And proportional odds is about dealing with things that move you in probabilities from one step to the next, right? So you got 3 steps and you have a probability of moving up each step, right? Now, a multiple linear regression is one where what you're modeling is actually a continuous scale. So imagine taking your staircase and just flattening it and making it slide, right? So now you can actually have a performance rating of 1.134 if you want to, right? Then you're modeling that, okay? Now, whether that would have given me very different results, I mean, first thing is it would have given me results that are not very interpretable, right? So I would have learned that each additional, I'm making this up, but each additional $1 million in sales gives you an extra 0.1 in performance rating. But that's meaningless, right? Because there's no such thing as an extra 0.1 in performance rating, okay? So it's not very interpretable if you use a multiple linear regression method for this. But you could, and it might give you some estimates of, you know, how much of this is explained. But by the model or things like that. But this is the thing. If you use the wrong model, then when the results come out, you're looking at it and you're saying, okay, I actually don't know how to interpret this. So I don't know if that helped answer the question, but that's how I describe it.
Well, I'm so glad that Hussein, you asked the question, and Keith, that you explained it there too, because it underscores something you started with, which is really understanding the shape of your data, the behavior of your data, and what it was trying to tell you to begin with, as well as you learn more about that. It gives you more information about likely methods that will be successful as well. So a data set is not a data set is not a data set in these ways too. So why don't we we'll open it up to some larger. One was a personal question, so we'll go this from Vitali, which is what field of math did you study before going into people analytics? And is there a field apart from statistics that you personally draw inspiration from?
Yeah, really good question. So my original graduate studies were in a field of linear algebra and matrix theory, for which only about 3 other people in the world could possibly understand what I was doing. And that was a big motivational crash for me. It's like, you know, am I going to end up, am I really changing the world if only 3 people understand what I'm doing? So, I think the second question is more interesting because there are actually lots of fields other kind of fields as inside mathematics, but also outside mathematics that I draw inspiration from. I'll mention 3 of them. So within mathematics, discrete mathematics, particularly graphs and graph theory. Graphs are a huge tool in our space if you have the right data. And I work a huge amount with graphs. You know, as I move on to think about what I might write about next, graphs is high in my mind. So that's kind of a huge area which fascinates me. And if you follow my social media posts, you probably see I post a lot about graphs on there as well. And so I'm very comfortable in that space because that's very aligned or close to the type of mathematics I did when I was a graduate student. 2 other areas, psychometrics, obviously. I mean, it's where my transition from mathematics to people analytics came through studying psychometrics. And I've designed, you know, and I still design, you know, psychometric tools, and I'm fascinated with how ability is measured and those sorts of things. So that's all very related. The last thing, and you'll probably see a bit of this in this book, is history, right? I'm an avid amateur historian. I read a lot about history. History is a fantastic way of understanding things because if you know how something originated, it gives you a better intuition for it. And that's kind of why I introduce some of the chapters in my book with kind of a little bit of historical context. And if you and that kind of helps. Okay, so if that's what they used to, if that's the method they used to solve this problem in the 1800s, that kind of helps me understand why this, you know, why this is so useful and why it can be of use to us today. So.
Keith, it's a wonderful call out on history too, particularly given that some of the methods that we're using today were incepted quite a long time ago, decades or centuries ago, but have kind of new applications and new unlock codes. I kind of think about the learning theory of the Kirkpatrick 4 model, where he thought of it in the 1950s, and yet you arguably probably couldn't actually easily get to execute on it until about 5 years ago.
Yeah, exactly.
As well.
Yeah.
To some nice broad questions here. So Keith, and we certainly have a number of HR analytics leaders and practitioners on the phone. So the question from Norma Jean is examples of some of the what high performing or kind of mature people analytics teams, the types of projects that we're all engaging in. As well, and look, I'll volunteer that when Norma Jean, that for many of our organizations is our primary focus is to be of help and use in decision making inside of the company. Someone whom I love and respect, Dr. Lori Bassi, who's done work in this area for decades, once said to me, the relationship between the complexity of the analysis and the value gained by the end user is not a straight line positive relationship. But I don't know, Keith, any thoughts there you want to weigh in on?
Yeah, I mean, I'd echo what Jeremy said, right? A successful people analytics team should be hearing feedback that they have helped contribute to meaningful decisions in an organization through the work that they've done. Let me give you an example, which might, from my work, which might, help illustrate. We were asked an interesting question last year by the head of our United kind of North American region. Our US operations were at that time were structured into 5 regional offices, right, in Northeast, Mid-Atlantic, South, West Coast, Midwest. And the question she asked was, how do people interact? Do they actually interact in office groups, or do they interact in some other way that we don't know about? And we were able to use graphs to pull in lots of data around interactions of people and use algorithms to detect communities inside there. And we actually learned that there are meaningful interaction groups, but they weren't in the local areas. They were in other ways, particularly around knowledge disciplines and things like that. And the direct, along with other things, that contributed to a decision which we made the end of last year, which is we no longer have that regional structure anymore. We're just one integrated United States office. And that's an example of real impact from people analytics. And that's the type of thing you want to be moving towards, right? You want your work to be brought into those meetings at the highest decision levels of your organization and contributing to those sorts of decisions.
Thank you for that. And so one more question, which is, so Keith, you sit in a very interesting organization. So you sit in arguably the premier strategy consulting firm, and your job is to provide insights, non-intuitive insights in analytics to a very smart, data savvy, and literally like they define strategies leading for around the world. How do you keep on top of these partners to link the work you're doing to their own business relevance? What is that? Do you find it? Do you think it's unique in talking to those peers that don't work in strategy consulting? Is there anything unique about this, or do you find that some techniques that you're using with these strategy consultants that you might not otherwise use?
So what I'd say is, I don't think there's any real difference from what I hear from talking to people who work in other organizations, right? I don't think there's any fundamentally different thing here from me working, at a company like McKinsey to other organizations. Maybe, McKinsey, people are known to be extremely analytical in nature, for a start. So you do get lots of detailed questions, and people are interested in the work that you do and they engage on it. And that's a positive thing. And also for McKinsey, people it's its primary asset, right? So it is extremely important. So I want to just make people aware that I am in a privileged position to work for a company like that. in this space, right? I don't necessarily have all the battles that other people might have to even show that people analytics is relevant. It's understood to be relevant, and we get a lot of questions and activities. But I think common with other organizations, communication is one of the key things, right? Because the traps that you fall into is if you don't communicate the results of your work. Well, first of all, and you mentioned this, Jeremy, understanding what people want is critical, right? Because what they say they want is not necessarily what they want, because language can be a big confusing factor in this space, right? So one of the things we've got very good at just through experience, I think, is making sure that we get the problem down as it is intended and meant before we go about solving it. And then finally, how you communicate the results back. And one of the big traps that you fall into, right, is people get so excited about the results that they go off and say great things about them. And what you have to do is rein that in a lot of the time. Because if your model, for example, says that something has a certain effect on an outcome of interest, as I said before, it might only explain a small part of it. So you don't want people going around saying it's the only thing that matters. Yeah. That can cause all sorts of other problems. And I think these sorts of things are things that you'll face in any organization. And that we've just managed over time to kind of get a production line running against them. So we know how to deal with it when we're getting in requests and also communicating results back out.
Thank you for that. And I'll, just one final on your McKinsey note, we'll go to just a slightly different space, is I think a lot of us are beginning to go to the data live with clients as well. So either at the endpoint of research up in Shiny or a different application, or in the data. Given your experience and how your particular firm operates, have you changed your methodology at all? Do you tend to go right to a notebook? Do you convert into slides? Like in that last point and kind of telling the story and influencing, what are you seeing?
Yeah, the way I describe it is, first of all, what does the client want? Do they want data and just a picture of how things currently are in the data? Because if that's the case, then, and presumably you get a lot of requests for that. The first thing is you just need an efficient way of delivering that to the client. So in our case, what we've done is we've got front-end developers who build professionalized looking tools that anticipate, they're built around an anticipation of what are 80% of the data questions we get. So people can actually go and just pull that for themselves, right? And that takes a huge weight off us. The second thing is the client looking for data, an interpretation of something or an answer to a question or interpret. In that case, it's a bit more difficult, right? Because there's a translation layer to that. And if that's the case, two things that we found valuable is one, have professional translators as well as data scientists, because the data scientists tend to like the data. They don't like to be stuck in lots of meetings talking about strategy generally. The translators like the strategy, but they don't tend to engage that much with the actual coding. Put the two together, you've got a fantastic equation, right? Because everyone's doing what they love. And that works pretty well in our case. But for that, we use a variety of things. We might use just the types of documents I've shared with you today if you're communicating about something complex, ranging to apps or online, reactive things. If there's lots of different ways we want people to look at something, we will spin that up so that people can play with it online to see the different cuts that they need. So there's a variety of methods in that space, but usually for a people analytics team, 70 to 80% is getting that reporting layer right, because otherwise you're going to be spending all your time sending Excel spreadsheets to people with data in it and not actually doing the interesting stuff, right?
It's a point well made, and I remember a conversation where we had worked, probably an entire team worked for a week on a particular problem, and the end result was two bullet points that ended up in a briefing document to the CEO for something. And when someone came back and said it was only 2 bullets, I said, well, was the right the question was answered. I mean, what would you like?
Yeah, that's the important thing.
Yeah, and in the format in which they needed it too. There's some great comments coming through as well, but I want to kind of close this out with one final question, and it has to do with your interest in ONA and the TV show Friends as well. So I'm gonna post a link up on the chat. But you've had a side kind of a side hobby going on for a little while. Could you tell us about the origins of your ONA visualization?
Yeah, and actually, I'm not a big fan of friends. Before I go into this, I mean, in the end, if you want to demonstrate something, you need like a data set or a set of resources that you can use to demonstrate it. And for me, I'm a constant learner, right? And I just want to learn. One of the questions that I ask myself as a challenge is, can I go from having nothing to understanding a complex situation, like literally having nothing to understanding kind of describing a complex situation? And particularly related to organizational networks, one of the things that I was interested in doing, saying, okay, let's look at a TV show, right? A TV show is a complex set of interactions between different characters, and the longer the TV show, the more interactions you have. So let's take a long-running TV show like Friends, and let's see if I could do that. And that was multi-steps and a huge learning experience. And I posted all the steps of it up online. So if other people want to learn how to do this, they just can. But you get the scripts, you pull all the structured parts out of them. You use natural language processing to work out who are the characters. You use natural language processing to work out which characters are appearing together in the same scenes. Then you turn that into a network by saying if they were in the same scene together, they're connected. And then, the number of scenes they're in together is a stronger connection. And then you analyze that and find out who's central to each network. And then you visualize it in a nice, pretty way. Normally what I post on LinkedIn is kind of the end of that, which is the pretty visualization.
Yeah. Yes.
But there's lots of steps that lead up to that. And for people that are interested in network analysis, and particularly coding network analysis, that's a really good example. But, I've watched Friends. I'm just not a fanatic of the show.
Well, and what the other thing that I really appreciate about how you got there is the challenge that you gave to yourself of starting from scratch, getting the toe in, determining an approach, and essentially manifesting from scratch. How is it? And that type of challenge, particularly for the portion of our participants here who are just starting out in an analytical endeavor and in data science, it's that challenge of not knowing, working from a blank sheet of paper, and then using all the support around you as well. That it's one of the most inspiring things about current learning today is that
absolutely,
if you'd like to learn it right now, you can.
Yes.
Too. For free out on, and it's the thing that I appreciate the most for you posting the book out as well. I think it's a great contribution to not just HR as a practice, but as we can see from the signups and the attendees today to the broader community as well. So thank you for that. So we're getting close to time, and first I just want to thank you, Keith, for spending some time with us. And I know it's later on a Friday, and this is how you've celebrated the beginning of your weekend, I'm sure, from a long week. And I really appreciate you keeping a few brain cells left for us after the week. For everyone else as well, one, thank you for coming, and if this has resonated with you and you think you've maybe found a home, come and join us for upcoming events as well. We will have at least one more event coming out soon on the 16th. I think Nigel Diaz is on the line as well from London. We will have I might not use the right words, but a World People Analytics Day sometime in March, is where we will have analytics teams from around the world. Stella, do you want to talk a little about that? Okay.
It's the 16th of March, and we hope to have a rolling series of meetups around the globe in different locations. So
if you'd like to learn 24 hours, you can learn for 24 hours on that day. I'm also going to post up to the in the chat here our Slack channel as well. Our group here, this meetup, we meet up in time sequence like this, but we do not have to do that for the rest of the days. So you're welcome to join the Slack channel The number of people that are on this call that have actually gotten a job or extended their career somehow from the Slack channel is not small. You'll see the link up on the chat here to sign up for it. Please use that if you are both sourcing for talent or you would like to be sourced for talent as well. Please avail yourself of that too. A lot of us are hiring in this area, and the talent base is growing and growing. So we look forward to seeing you on there as well. And if we haven't already linked in to you, know that we're all friends here. So if you want to come and say hi on LinkedIn, and we might not be able to chat for hours and hours, but please extend your network and learn something. You know, the key thing that I think about a lot is that the pace of change, it has grown so quickly that I kind of think about this, if I were to roughly call it a non-linear pace of change. Humans only learn at a linear pace, which means you need more of us together as well. You can't do it alone. So gang up on this, learn faster, accelerate your own careers, accelerate your understanding by kind of using networks, using the people around you to learn more too. So with that, thank you very much for everyone who has joined. Thank you again, Keith, and to the organizers as well for all of us. This is the passion that we bring to the table, and our hope to share our understanding, knowledge, and improve our organizations and the world as we can too. Please, everyone, stay safe, stay healthy, and we hope to see you soon, either live or online. Yeah, take care, everybody.
Thank you.
Carry on.
Good night.
Thank you.